Okay, we're going to solve another first order ODE using an integrating factor. This is going to be the hardest example out of the group of these type of examples, just because in this example we're going to solve a first order differential equation that has an initial value and that has a restricted domain. And I will explain more about that when we get to the example. So remember what it means for the equation to be in standard form. It just means that basically y prime has a coefficient of 1. Okay, this is our example where y prime has a coefficient of 1. And if you compare this equation with the equation number 1 shown earlier, you can verify that p of x is the cotangent x, that's the coefficient for y, and g of x is what's on the right side of the equal sign, that's for sine x. This problem, it also comes with an initial value, namely y of negative pi over 2 is equal to 0. You'll have to remember that that means that y equals 0 and x equals negative pi over 2. That's going to be important later when we're needing to solve for our arbitrary constant. Okay, I've rewritten the example so that cotangent x is expressed as cosine x over sine x. This will help us solve the integral easier when we're wanting to find the integrating factor. And it also points out that sine x cannot equal to 0. That is because we're dividing by sine x. And that's what I mean right there. I've boxed it in red. Remember, you can't divide by 0. And that means that we need to restrict our domain for our x variable so that it will be an answer for this particular differential equation. And basically what that means is we just need to find our domain for x. Okay, so when we're wanting to find our domain of x, basically you just set sine x as not equal to 0, since we don't really care what value x is or sine x is, as long as it's not equal to 0. And therefore that means that x cannot be any multiple of pi, that whether it's a negative multiple or a positive multiple or 0, it doesn't matter. X cannot equal any multiple of pi. So I'll just draw a number line. And remember, since x cannot equal a multiple of pi, that means it cannot equal negative pi, 0, or pi. But x is free to equal any value between these points of discontinuity. So x could be anywhere between negative pi and 0, or it can be between 0 and pi. But remember how they gave us the initial value. They said the initial value was x should be negative pi over 2. And since that falls between the interval of negative pi and 0, that means that our interval for x, the domain of x, should be between negative pi and 0, but not equal to either of those two endpoints. Okay, so now we can get back to actually trying to solve the problem. Because, once we figure out the domain of x, we just need to throw that in at the very end. But to actually solve the problem, we should progress just like any other problem of which we're using this method. We need to create an integrating factor, namely that would be e raised to the antiderivative of p of x, which in this case was cosine x over sine x. And when you simplify that, that would be e raised to the power ln of sine x. And that just simplifies to mu equals sine x. This next step is always the same. You don't have to think about it at all. Just write down this equation, and remember I've explained it in the first two examples, so I won't explain how to get this equation again. But once you figure out your integrating factor, you just write this equation down and go ahead and fill in what your integrating factor is and what g of x is. And after making those substitutions, you'll end up with d dx of sine x times y equals sine x times 4 sine x. And this can be simplified so that on the right side you'll have 4 times sine squared x. After that, remember we're always wanting to solve for y, and so we can just multiply by dx on both sides. And then we'll need to take the antiderivative on both sides. Remember, on the left side, they just cancel out, so you'll end up with sine x times y equals 4 times the antiderivative of sine squared x dx. So in an effort to make this easier to at least understand, I won't go through how to solve for the integral of sine squared x. But I've listed the answer here, and I've tacked on the plus c. And when that simplifies, it would just be sine x times y equals 2x minus sine 2x plus c. Or you can divide by sine x on both sides, which is what you're going to want to do, and you'll get this quotient 2x minus sine of 2x plus c over sine x. This is one of the last steps. Ordinarily, you could stop here and this would be your final answer, but this time they've given us an initial value, and so we need to go through and plug in the y coordinate and the x coordinate that they've given us in order to solve for the value c. So remember, everywhere you see a y, you're going to want to insert a 0, and everywhere you see an x, you just plug in negative pi over 2. And this will all simplify so that you get c, your constant, is equal to pi. And now the last thing to do is, once you figure out what c is equal to, you go back to your answer where you have y equals, and you just plug in pi for c, so that you'll get y equals 2x minus sine of 2x plus pi divided by sine x. Or you could write the answer in terms of cosecant x if you don't like writing it as a fraction with sine x on the bottom. That would be the same. Just don't forget that you'll need to include your restricted domain in there, letting whoever know that x is only valid between negative pi and 0. Well, that's it. This is just one of the harder ones. Of course, anything else would just be a similar example, so I won't make any more of this type. If you like watching the examples, just leave a comment or like it, just so I know that at least someone is being helped.